Hi everybody, and welcome to my presentation on what is new in the databases. But let me start by answering the question, why are there so many databases in FactSage? The reason is that each and every element in the periodic table constitutes one dimension in chemical space. So the chemical space analogy is a good one and a bad one, because on the one hand, chemical space is just like real space, extremely large. But on the other hand, it's a bad one because real space is just three-dimensional, while chemical space is essentially 90-dimensional with the 90 elements or 91 elements we have on this planet. And then we are also interested in quite different properties from Gibbs energy to bulk matrix volume, heat capacity, viscosity. You know what you need as material scientists and metallurgists around the world. So the 90 dimensions cause a problem for us because as the databases grow, the number of additional systems that we need to evaluate if we add another element to a database is increasing linearly for the binary systems, but with a second order for a ternary system, which means that for the 30th element in a database, we need to evaluate more than 400 ternary systems if you really want to evaluate all ternary systems. So that means it's just practical to narrow down the database development into different application fields. So I will talk today about a new database, FTsulf. That will be the starting point. Then about the updates in the FToxide, FTsalt database, updates in GTOx, updates in the metal database. I will talk a little bit about physical properties. That was a meaningful update over the last years. And then I will talk about AAMP and another new database, AAOQ. And in the end, I will just give a very short outlook towards FTSage, which is now called Calvert Optimizer, a new module. So FTsulf, that is probably the biggest update in terms of databases. With FactSage 8.2, FTsulf is a new sulfide database that is included in the FactSolutions database package. So if you so far had access to FTMISC, you will also have access to FTsulf. In FTMISC, there were 10 different liquid phases, 7 of them describing liquid metals and 3 describing liquid sulfides. And all of these are now combined in the FTsulf database developed by our partners in Montreal into one liquid phase describing both the liquid sulfide and the liquid metal. So there's an overview of the optimized systems. You can clearly see that that is designed for the non-ferrous metallurgical applications and the smelting applications. And that database, the FTsulf database, should be used together with FToxides, FToxide FactPS and FS Steel for the intermetallics. Now to the updates in FToxide and just a little bit of a timeline also to put everything in perspective. In 2019, many systems containing potassium oxide had been added to FToxide. Oxyfluorides received an update, and also the manganese 3+ was added. 2020, the lithium oxide was added in systems containing also alumina, calcium oxide, potassium, magnesium, sodium, silica, and fluorine. 21 vanadium oxides were added as a major update, and now in 8.2, which will be released in the next 2 weeks, copper, nickel, arsenic, and sulfur have received an update, which is of course corresponding also to what was needed for the compatibility with the new FTsulf database. In addition, physical properties have been included now also in FToxide, and the viscosity calculator is now roughly 10 times faster, actually because the backend now relies on ChemApp, which is a good thing if you want to have fast calculation results. The FTsalt database was completely restructured in 2019. So, for example, there's now only one rock salt phase, while there had been different rock salt phases before for chlorides, hydroxide, fluorides, and so on and so forth. In 2020, the nitrate equilibrium was included for the sodium potassium, and then in the year after that also including then chlorine and perchlorates. And then also last year, FTsalt was the first database, or one of the first databases, where physical properties had been included, meaning density, thermoexpansivity, and heat conductivity, or thermoconductivity. And then this year, lithium is also added to that system, so now you're able with FTsalt to calculate whatever you want to do in terms of for the popular solar salt, and also there has been another extension towards physical properties. The GTOx database, so that is the GTT oxide database, that had also vanadium oxide added in 2019, so a little bit earlier than FToxide. 2020 was a rather minor update with strontium oxide and nickel sulfide added. And then 2021, 1 year after FToxide, also lithium oxide had been added, but in GTOx you also find systems containing transition metals for lithium oxide, which is of course important if you want to model lithium-ion battery recycling. This year we have added copper oxides to the GTOx database. We have a major update on the nickel oxide, especially sodium, potassium, magnesium, calcium, sulfate, chromate system that's important for hot corrosion, and also a first slag density model is now included. And if you have also ChemSheet together with GTOx, you will have access to the viscosity calculator, where you can input composition temperature and oxygen partial pressure, which is usually easier to input than iron 2 plus, iron 3 plus ratios. And in the output, you also get viscosity of suspension systems and mass fraction of solid phases also. In the metal databases, FSsteel was or had received a really large update in 2019 with a completely remodeled liquid melt, and then also additions for high alloyed steel, zinc galvanizing applications. And then 2020, 21, 22, there's now a development to make the FSsteel database more and more compatible with superalloys and high entropy alloys. And this year, the biggest update is something like 80-90 systems on rare earth elements. That's of course important if you want to model neodymium magnet recycling, but also if you want to see what is the impact of the increasing rare earth concentrations you see in steels. The S3D Solutions database is receiving continuous updates, so there will also be a new S3D Solutions database in FactSage 8.2, and roughly there are 50 new systems added per year. And the same growth rate is also there for the SPMCBN non-oxide refractory materials database, so silicide, carbide, borides, nitrides. Concerning other metal databases, the FTLite database, actually all FTLite, FS copper, and FS lead had received a major restructuring or major rewrite in 2019, and now there is also again a major update in all three databases with a large number of additional systems that are included. And I just give here numbers on the binary systems, but of course there are also ternary and quaternary system that are added and updated this year. For FTLite, you will also now find physical properties in the database. And if you haven't done that yet, if you're interested in thermoconductivity, then you should try the microstructure app that you can start now from the FactSage main menu. and in order to define what is your porosity and grain size. And after you've done that, you can use in Equilib the use volume and physical properties data option here. And when you calculate, you will then get the output on thermoconductivity of a microstructure. If you're interested in more information on that, please visit the slideshows on physical property calculations and thermoconductivity of microstructures. So AMP, the Ab Initio Materials Project database that's developed by us and built on ab initio calculations and machine learning models, is also receiving a major update this year. So AMP now contains 128,000 compounds. We take the enthalpies of formation from materialsproject.org, and then we now have a machine learning model on the consistency modification to make the data as consistent as possible with our existing databases in FactSage in terms of their enthalpy of formation at room temperature. There is a new machine learning model for heat capacity at different temperatures, and also the machine learning model for S298 was updated. And in addition, you will find still there was no update, the DFT calculated enthalpies of mixing of the FCC, BCC, and HCP phases in 1400 binary systems. AMP now has a new family member. So there is a little sister of AMP, which is the AAOQ database, and actually the little sister is quite big, containing now data on 718,000 compounds that are taken from OQMD.org, so the Open Quantum Materials database. And other than that, the models are developed in the same way as we have them for AAMP. There are a couple of use cases for AMP and AOQ. So they are used internally to improve our data quality also in the existing databases. They can supplement traditional CALPHA databases when you don't have experimental data. You can use them for materials informatics applications. I think I presented an example at a users meeting 2-3 years ago. And they can serve as an excellent starting point for CALPHA assessments. For example, if you use the newly developed CALPHA optimizer. So that is just I will just end this talk by a short announcement that the old FTsage is now called CALPHA Optimizer, and it is a very nice program if you're interested in database development because you're missing some data in the FactSage databases. And more details you will hear about that in the next presentation by my colleague Bruno Reis. So with that, thank you very much for your attention, and if you have any question, please take the chance and ask them now.